Okay, good morning everyone, and welcome to
PETROWEEK Course 2020, Python for Exploration and Production 4.0.
Let us introduce ourselves. My name is Boykedeo Sihite, and together with my partner,
My name is Michelle Keja, and we will gladly guide you in today's event.
before we proceed to the main event, let us start the day with a prayer for the well-being and safety of the event. Let us all pray according to our own beliefs. Let the prayer begin. Amen. Now, before we continue, we would like to say thank you to our beloved sponsor,
To ExxonMobil Chippo Limited as our gold sponsor,
Telkomsel as our gold sponsor,
Medco Energy as our silver sponsor,
Premier Oil as our silver sponsor,
and Pegen Saka as our silver sponsor. Now, let's hear the opening remarks from Mr. Gilbert and Ms. Prilly as the Project Manager and Vice Project Manager of PETROWEEK 2020.
Good morning, everyone. Greeting from Trisakti University, Jakarta. With all due respect, Mr. Yohanes Nuwara and all the participants. First, let us thank God who has given grace and health so we can assemble in today's course.
First and foremost, on behalf of the PETROWEEK 2020 committee, we would like to give our biggest gratitude to Mr. Yohanes Nuwara for spending his valuable time on being the speaker of today's course.
And all of the participants from the various places, could it be from Asia, Europe, America, and many more. We highly appreciate your enthusiasm in today's course. Even though we are still in pandemic circumstances, which forbid us to go outside and require us to stay indoors. But all of you choose to keep moving forwards to enhance your knowledge for the greater good.
PETROWEEK 2020 course events are hosted in Oil and Gas 4.0 towards production, prospect optimism. This course will give us insights into how to maximize the potential of digitalization in the oil and gas industry by examining the use of Python programming language.
In other words, the oil and gas industry invests majorly in AI and other data technologies to secure their future competitiveness during a fast-changing environment.
For that reason, let us all grasp this moment as an opportunity to make the better versions of ourselves. How? By learning something new every day. Every human being is given the ability to think and explore. So, let's use our intelligence to move forward for the sake of the future of mankind.
We look forward to seeing the positive outcome of this event.
Thank you for your attention.
We hope you enjoy the event series of PETROWEEK 2020
PETROWEEK
from Home.
Okay, thank you, Mr. Gilbert and Ms. Prilly. Before we move on with our event, I'd like to state my appreciation to Mr. Yohanes Nuwara for providing the time to share your knowledge with us today. I would additionally like to welcome all of the participants, wherever you may be, who've taken the time to liven up into this course.
Today's theme will be Oil and Gas 4.0 towards production prospect optimism. Hopefully, this event could enrich your insights for the future of the energy industry and to encourage yourselves to expand your abilities to the max. Joining us here today, we have the Honorable Mr. Yohanes Nuwara as a programmer at Github, also as a geophysicist engineer.
He was born in Jakarta on the 19th of March, 1997.
He has a Bachelor of Science degree in Geophysics from the Bandung Institute of Technology.
He has many skills, such as seismic interpretation, reservoir characterization, scientific computing, and numerical simulation.
Not just that, he also has many experiences, such as a research intern in Fukada Geological Institute, Tokyo, and as a summer intern in Marietta College, Ohio.
Ladies and gentlemen, today we are going to learn more about the future of the oil and gas industry, in specific about the use of Python in the process of exploration and production.
Yes, that's right. Python is an interpreted, high-level, general-purpose programming language which could help programmers write clear, logical code for small and large-scale projects.
Wow, isn't that something? Now guys, before we continue, we are going to read the rules of today's event. First, you must be registered before the event.
Second, you must join the Telegram and WhatsApp group.
Third, you must attend the course webinar on Sunday, 13th of September 2020 at 10 a.m. through the CloudX platform.
Fourth, please use your name as registered. Otherwise, you will not be admitted into the meeting room.
Fifth, your camera must be turned on and you'll be muted during the presentation. If you have any questions, do hold it until the questions and answer session.
Sixth, you are not allowed to exit the room, excluding for internet purposes. Once you are out, there will be no joining back in at all costs.
7. The recording of the presentation will be uploaded to the SPE Trisakti Student Chapter YouTube channel.
8. All of the rules above must be followed in order for you to acquire a certificate at the end of the event.
For today's attendance, we are going to have a photo session in the beginning and end of today's event. So guys, I would like to ask you to please turn on your camera for us to see your beautiful and handsome faces. And don't forget to unmute yourselves.
Okay, guys, please turn on your camera so I can see you all.
And don't forget to unmute your microphone.
To all of the participants, please turn on your camera so we can take a picture together.
Okay. On the count of 3, say PETROWEEK. 1, 2, 3.
PETROWEEK.
Once again. 1, 2, 3.
PETROWEEK.
Okay, thank you so much, guys. Okay, guys. Today's event will be divided into several sections. First will be an introduction to NumPy, Matplotlib, and Pandas. Next on our list, we have a view on exploration data streaming and basic petrophysics using Python. And last but not least, we have well test and decline curve analysis.
In between each session, there will be a question and answer session. So prepare yourselves to stay comfy. But if you have any questions during the presentation, feel free to write in the chat box.
By that, to Mr. Yohanes Nuwara, you may now begin the course. The floor is yours. To Mr. Yohanes, can you hear me?
Okay, I just forgot to unmute my voice. Okay, it's okay. So, good day, everyone. My name is Yohanes Nuwara. It's a Sunday morning in Indonesia. I just see lots of participants are joining in from all around the world. So I just say good day because I know that you are experiencing lots of time zones. There you have morning or in the afternoon, or in Bolivia or South America, you will experience in the evening right now. So I just hope that all of this session will inspire you to learn more about Python. So first of all, I would like to say thanks to SP Trisakti to hold this really precious meeting and to allow me to share my knowledge and my skills in Python to you, so that all of these skills will be applied to you for your works, for your studies in the future. And then I would like to say thank you for all the participants. There are lots of participants, hundreds of participants. I just really surprised to see that at the fourth and fifth day, I just saw about 300 and 400 participants are registering in this course. It's really, really surprising for me. And right now I just see hundreds of participants, about 115 participants. I hope you are enjoying this course. For the next sessions, we will have 3 sessions. So bear with me. If you have any questions, you can ask directly into the chat feature, or if you want to unmute yourself, you are advised to unmute yourselves in the break time. We had a break time, so you don't have to feel so stuffed with this Python practices. You can just feel free to ask me or interrupt me in the chat feature. If I look in the chat feature, I will answer your question directly. Or if I don't see your message or questions, you can ask in the break time. Okay, for without further ado, let me start sharing my screen. Okay, there you go. Okay, I hope that this presentation is visible to all of you. How about Boyke and Michelle? Are you seeing the presentation right now?
Yes, we can see.
Okay,
Yes,
so if you have any issues or technical issues, you can report in the chat feature and the committee will help you. Okay, so let's start our session today. Okay, okay, this is the introduction to Python. So basically what we'll do today, we'll go through 3 sessions. The first session, we'll discuss lots of applications, basic applications of NumPy, Pandas, and Matplotlib. Well, these 3 libraries are really basic. So you have to master these 3 libraries in order you to master the applications of Python in your works. Of course, this is the course for petroleum engineering, but I just see lots of participants from from different majors, like in economy, astronomy. There are lots of majors are tuning in today. But I hope that you get the essentials from this course, of course, and then you can apply You can search in the website. There are lots of applications there in your majors. For example, you can learn machine learning from lots of websites. Right now, I'm a writer towards data science. I write sometimes 2 articles so far about the applications of Python in petroleum engineering. Okay. There are lots of applications right now. You can learn from lots of resources, but I hope this course will bring you introductory. Okay, I forgot one thing. Last week I said that there are free courses in data camp, so I hope that you already had taken the courses there. I believe so. So before this session, I hope that you understand the basics of it, how to operate NumPy, what is NumPy, what is Pandas. It's really important before we start the session. So don't worry if you haven't had taken that course. We'll go through that in brief. Okay. So what I'm gonna say that Python is a programming language. If you are hearing lots of terminologies like NumPy, Pandas, Matplotlib, Seaborn, what is more, SciPy, or even Keras, TensorFlow, scikit-learn, they are libraries. They are not programming language. The programming language is Python. Okay, and you may hear about IDE. That's not a programming language like PyCharm, Anaconda, Jupyter, lots of the names of the animals like there, spider, or Google Colab that we'll use it today. It's not a programming language. It's an IDE where you can code directly into your PC or into your online. And the advantage of using Python is that you can run the programming language in the cloud. So whether you are running online or offline, you can code anywhere. So that's the advantage of Python. And Python cannot be alone. Like human beings, we really need best friends. So NumPy, Pandas, Matplotlib are the friends of Python. They are libraries. Without those libraries, although we can code with a pure Python, but these libraries are really core for our applications. If you are analyzing data, you need Pandas. If you are making an array or handling with multi-dimensional data for machine learning, you have to master NumPy. So this is basically the 5 main libraries of Python. You can see that through this first session, we will cover NumPy, Matplotlib, and Pandas. Although Seaborn and SciPy is also interesting, but we'll go over it. And if you have any questions during the course, or if you want to ask what is Seaborn, what is SciPy, and what is important for me, you can ask directly. Okay, so I'm going to discuss the outcomes from the first session. In the first session, you will introduce to Google Colab. So you are maybe you are doing your codes in any IDEs like VS Code, Virtual Studio, or PyCharm. This Google Colab, you can run the Python in online. So just make sure that your internet is stable for now. And if when you are going to code Python in Google Colab, just make sure that the internet, but it's not an importance at all. It's more important to design your code in the first time. And then if you are really confident with your codes in online, in the Google Colab, you can directly code in the PyCharm or in any IDE. And then our main course will be, we will understand what is an array. Actually, array is the basic topic in the programming, in any programming language, in MATLAB or C++. Array is the firstly discussed topics in the programming language. So we're gonna understand what's an array, and then how to handle arrays and how to understand what's inside the array. If you have a 1D or 2D, two-dimensional arrays, or even it can be 3D or 4D, 5D, they are we cannot prevent the dimensions in the data. It's really natural. So you can, if you can operate with these libraries, you already master that. Okay, so the first session will be in NumPy, and then the second part of the first session, we'll discuss mostly about Matplotlib. It's a library for plotting. I see lots of plotting libraries like Plotly, and because I'm from geoscience background, there is a really good library for plotting. It's called PyVista. PyVista is also built by a geoscientist, so you can use PyVista to visualize complicated design, whether in Matplotlib you cannot do, but the basics of plotting is inside the Matplotlib. If you are mastering Matplotlib, you are ready to apply plotting in all kinds of data. And then the third part of the first session will be you're gonna learn about the data frame. What is a data frame? Well, if you are right now working, I believe you are all working with Excel. From high school or elementary school, you are already introduced with Excel and how to work with it, how to code the formulas in Excel. And data frame in Python is really like Excel. It's similar to Excel. It's a spreadsheet. But in Excel, you can just easily tune the formula and then drag the columns or the rows that you want. But in Python, you will code one by one to access the data frame and then to make the data frame. Okay, I just saw some comments in the chat feature whether my voice is unclear. So I'd like to ensure all of you participants, if you hear my voice clearly, you can type your comments in the chat. But I'd like to ask of all of you if you are hearing my voice. Okay, thank you, Daniel. Thank you all. Okay, so yeah, because it's dependent on the internet. If we are gathering directly in a room or in a seminar room or in the lecture room, there will be no limitations on sound because it depends on the internet. So I hope that some of you will hear me clearly. I'm really glad because right now I cannot even hear you because we are limited by the time zones and by the Zoom. But I hope that you can follow my explanations. Okay, so these are the outcomes from this session. So okay, just directly start. Okay, here you can visit this link to open the notebook. So what we're gonna do now is that we're gonna open this link to view our notebook today for practice. So you can just type this URL in your laptop. I hope that you are using laptop right now to code and to open this link. So if you have already opened this link, you will directly go to the notebook. Okay, here you are. You will see this notebook. So have you already opened the notebook or okay? So here's the notebook that we're gonna practice today. So we won't practice our codes in PyCharm or in IDE because this is really easy to code your codes in Google Colab. Okay, so in this notebook, you can scroll down for details. So this is our notebook today. Okay, so I'd like to say that in this notebook, you even don't need to download any data because the topics of today course is streaming data from production and from exploration. So you don't need to download your data if you are using Google Colab. So it's the advantage of, or it's the power of using this online free and open source IDE for all, so you can even code 24 hours without any interruptions, of course. And then the data that we're gonna use today, it's in my GitHub. So if you are already here about GitHub in LinkedIn, I often post some articles there and some applications, some codes that I posted in Google Colab, and then I just type the GitHub. Well, GitHub is a place for you to store your codes. Whether it's not mean only for Python, it can be Matplotlib, it can be C++, but it's really advised for you to store your codes. If you are studying right now in the university, or you are building a new program, it is advised to you to store not into your computer, but into a safe repository like GitHub. So I'd like to show you what is GitHub like, how does it look like. You can click on it. This is the repository for today's session. I just place the data here, and then this repository is meant to build in the future. I want to build like a bootcamp for geoengineers. It's a really enthusiastic people out there to request for bootcamp for geoengineers. So I want to initiate this for all of you. So I'm glad that this course is my first course. So I'm really proud to place the PETROWEEK by SP Trisakti in this in my first page of my GitHub. So this is the notebook, and you will see lots of data here. This is the data. If you click here, you will see the data that we will use for today's training. And in the coming days or in the coming months, I will continuously update this repository, so you can continuously learn from this repository. And then if you have any questions or any you want some advice on how to start all of these things, I'm really confused how to start all of them, like machine learning, data science. It's really out there. You can just contact me directly in LinkedIn or in Telegram, because we are in Telegram right now. Don't leave the group after you are joining, because you can participate in discussions. I don't limit all of the interactions in the group. You are free to ask anything, and you are free to talk with each other, to talk about lots of things. It's up to you guys. Okay, so right now we have about 15 data sets, I hope so. And what we're gonna do today is that we're gonna stream this data directly without any download. Okay, so this is the structure of our workshop. We're gonna back to our notebook. This is the structure of our workshop. The first session will be Unit 1. So you can directly click on this link, the Unit 1. You will see a new notebook appearing there. So it's already designed for you, all of you guys. You don't need to write a new code. You already had all of the codes there. Okay, so I already made these codes, and I will explain you step by step. But don't worry, you can add your own codes in this notebook. So it's not a general notebook. You keep your notebooks like it's not a notebook. It's a virtual notebook. You can add your codes. You can remix your code. Okay, and then you can share this notebook to others. Okay, so right now we are seeing lots of codes right here, and I'm gonna explain one by one. Okay, so if actually you can start right now by clicking connect here. So it's connecting the Colab notebook to the internet, and after being connected, you will see. So this one is the process of connecting, and if you see this checklist, you are safe. Okay, so actually with this notebook, you can code directly. For example, I wanna make an array. For example, it's just basic array like A equals 1, 2, 3, 4, 5, and then if you print A, you will see the results. Okay, so if you are seeing this message, this notebook, it was not offered by Google, don't worry. You can click run anyway, and you will see your results right here. So I guess that any programming language is initiated by print, like print hello world. Okay, so it's a formal introduction to any programming language. I know why lots of people are using hello world to initiate, but I guess it's a tradition, it's a culture from any programming language in the past. Okay, so it's not important actually. It's more important to understand all of these codes. Okay, so basically, in the first step, you just clone the repository. I'm showing you the repository. This is the repository. Okay, and then what we're gonna do now is that we're gonna use this repository in your notebook. So you can just click the run. Okay, it's already cloning here. Okay, so you can run this cell by clicking Control and Enter. Okay, so if you have already cloned this repository, you are safe. You can see this the files here in the left pane. You will see the Python bootcamp for geo engineers here. You have all the data and then the notebooks that we are using right now. So, okay, after all set, so the first thing in any in Python, you initiate with this libraries. So there is NumPy, Matplotlib, and pyplot. You're gonna code like this way: import blah 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 as blah blah blah. But you can even modify this, like import numpy as your name. For example, my name is like import numpy as Yohanes. Okay, so it's free. It's up to you. You want to name your libraries with your name, that's okay. But okay, so I can run this, and then I can directly use this like I want to check the what's inside the numpy. So actually, it's not too urgent for now. It's you can use any name, but in the formal programming, you just click like this: import numpy as np. So you can directly run this code, run the cell. Okay. So after this, you will have your all of your libraries inside your notebook. So don't forget to get all of these libraries first before you initiate your program. And one thing, Google Colab has already downloaded the libraries. So if you are using PyCharm or you are using Anaconda right now, you must be installing all of these libraries in your PC, but in Google Colab, it's already installed right there. Okay, so when we are finishing with this cell, so let's directly go to NumPy, and then you can see we'll start by how to make an array and how to make a set of numbers in an array. And then I have already prepared all of these codes, and you can just run these codes. But if you want us to code one by one, that's okay. I think that's really that's the essence of programming. So okay, so if you are going to make an array, you can just type this np array, numpy array. Just input your numbers like like this ones, and just click the run, you will have your array. If you want an array that starts from a number and ends with a number, and you want to have 100 numbers, you have to code like this. Okay, so linspace is a function to generate the numbers from 10 to 100 into, for example, 50 sets of numbers. Okay, so this is designed to do so, and then you can also make an array that consists of numbers from 10 to 100, but the method is different right now. Um, you use a range, okay? You use a range and then just type from 10 to 100. But right now, the third syntax is not the set of numbers that we want to generate, but the step of number. So for example, you want to generate from 10 to 100 with a step of 5, okay? With a step of 5, you will get these numbers, okay? So you understand what's the difference between a range and linspace, okay? Although at the first time when I learned Python, it's about 1 year ago. I just learned Python for 1 year right now, and about a year ago when I just started Python, I don't have any idea why the arrange is without double R, like in a common English language. We use this kind of like arrange with double R, but I didn't have any idea why my code didn't work, because I was really sure that I have typed the right syntax, but it doesn't run. So I just asked the instructor at the time, what's my mistake here? Oh, you just add double R. Okay, that's weird, but yeah, that's how Python is written from its inventor. So okay, so it's really fun to learn Python. You just find lots of trials and errors when you are learning. So, but that's okay. That's the step of your learning cycle. The more you get lots of errors in your codes, the more you learn. So when I learned Python for the first time, I use 24 hours, maybe it's not 24 hours, but 22 or 23 hours to look in the Stack Overflow. So this website is really advice for you to learn Python, not from the courses, but you will see lots of people right there are posting their questions and their threads on how to like find the numbers of duplicate values with pandas. This is really simple actually, but all the beginners, all the experts are using this to find their mistakes and to learn something new from this. So it's really advice for you to do trials and errors before you are already mastering Python. Okay, so without errors or without any issues, any bugs in your codes, you won't learn anything. If you just learn from the courses and then you stop learning without practicing it, you don't learn anything. Okay, so I hope that after this course you are interested to continue this learning, and you can build your own programs, simple programs. And if you are having errors, don't worry, that's your learning cycle. You have to continue with that. Okay, so we're gonna back to our notebook here. We have already had the numpy how to set an array. So if you print how many the length of this numpy, you can just click this len of the array. Okay, so it's simple anyway. We can proceed right now. So okay, so we will continue with how to set an if and for loop. Okay, in this example, I print all of this lengths of the array with these 3 codes. You see that it's really repetitive and it's not effective at all if you are building a program. So actually you can automate your process using loop or for loop conditions, okay? So right here we have, I just merged all of the array here. We just built array 1, or the second array and the third array. I just combine all of these arrays into one array, and then I just click. I just run for I in range. Okay, so that's actually that's understandable, and print the length of the array through this loop. If we are running this code, you will have the same result as the above, but the only difference is that you have already automating all of these codes. Actually, if you have more than 3, like 100 arrays, it's not possible for you to print all of the arrays using these methods. So why we use for loop, why we use like while or if, it is the automation process. You can automate your process by using this 4 lines of codes. So you have to understand what is conditionals before you are studying a programming language. This is the basic of the topic in the programming language. Okay, so actually I can make also like some codes here. So for example, like we want to print each element in an array. So I'm gonna make an array, new array. Okay, and then I want to use the arrange method to generate numbers from 0 to 25 with a step of 0.5. Okay, so what I'm gonna do now is that I want to print all of the elements in this arrays, but one by one. So if you print this code, you will see this result, but I want to make a code that print the elements in this array. So what I'm going to do now is that I will use the for loop, okay? And for I in range, like in range, so range is how many loops that this code will do and will iterate. Okay, so we'll iterate through the length of this array. So we just use you remember how to make how to produce length of array. It's called len, and you type the new array. Okay, and you end the for loop with semicolon. Okay, so if you want to access your array one by one, you just click print, you just run print, and then you array with this I, and then you will get this sets of numbers one by one. Okay. So it's simple anyway. You can practice these codes into your laptop right now. And then in the next session, we'll use many for loops. Okay, so after this, we want to sort the array from the smallest number to the highest number. So we run this numpy sort to sort this number from the smallest to highest number. Okay, so this is the smallest to highest number, but how to reverse an order of sorting? Okay, so we can use this array, and then you can use this. Okay, so it will reverse your sorting sequence. It will sort from the highest to the smallest. Okay, and then you want to call the first and the last element of your array. Okay, so of course, like if you are having like an array, you want to access the first and the last element, you can use this. Okay, so I forgot to tell you that Python is different from any programming language in the way Python defines the first index. Okay, so if you are practicing with Matplotlib right now, you will access like this. Okay, so we have already made an array. Okay, this array, and in Matplotlib, you access the first element by passing this syntax by 1 or the first element. But in Python, it is different. So we'll see that in this array, we see that the first element is 0. And if we type 1, and if we assume that the first index is 1, we will have the wrong answer. Okay, so that's interesting. So this is the one that you have to understand. Python starts the element from 0. Okay, so if you type 0, it will correctly print the first element. Okay, and then the rest of the index is like if you pass the 1, it will print the second array. Okay, and how to access the last. Okay, so because a girl, the answer for highest to lowest is wrong. Okay, so let me check my code. Okay, from highest to smallest is okay. Sorry, it's not how we sort the numbers. It's how we reverse the elements. Okay, so if we have an array from this number to the last number, it will reverse. Okay, it will reverse the order or the elements. Okay, not the numbers. Okay, so if we are going to access the last element of an array, you just use this -1. It will print the last element of an array. So we have array here, and the last element is 24.5. So the last element by using the syntax is 24.5. And we are going to print the last 2 elements. We just pass this one, -2, and this the 24. Okay. So I think that's all for the arrays on how to access an array. So this has been already discussed previously. The last element and the last 2 elements. If you are going to access the, for example, the last 8 elements of n. Okay, sorry, of the array. Okay. So you can use this. This actually we have already made another array, -8. Okay, so it will print all of the elements from the array. So this is another array. Okay. Okay. So right now we are going to understand how to access the first 3 arrays of our the first 3 elements of our array. So we are only passing this codes. Okay, it will print all of the elements from 0 to 3. Okay, to the 3rd element. And then if we want to access the array from the 5th index to 8th index, we use this. Okay. And then this, the last 4 elements of the array, you can use this. Okay, so let me explain to you all. Okay, so for example, I already have an array like this one. Okay, the new array that we are creating, and then we want to access the first 3 array of this new array. So we use this. Okay. If you want to access the last 3 elements, you just move this semicolon. Sorry, it's not the last 3 elements, but all of the elements that started from the third index. Okay, so we have this array. If this might be confusing you, this array. Okay, this array. So it will start from this third index. Okay, that's understandable. If you want to access from the third index to the sixth index, you just add the 6 and then you get only the elements in the array. Okay, so it's enough with the 1D array. We'll proceed to the 2D arrays or matrix. Okay, actually the method of creating a 2D array is quite similar to how we made a 1D array. Okay, so the conventions of the metric is that we access this element by the row and the element. Okay, so actually we can continue this. Actually, we can like specify the first row consists of the first array, and then the second array and third array you can stack with the numpy array. Okay, so you can run this code. You see that these 3 rows have been stacked together into a new array. Okay, so this is the naive method to make an array. Actually, we can directly use this build the array. Okay, so there are 2 brackets right here. It's different. If we make a 1D array, we use only 1 bracket. If you are creating a 2D array, you use 2 brackets. Okay, so for example, 1, 2, 3. Okay, and then the next is 4, 5, 6. Okay, and then you print that, you will see the 2D array. Okay, so how to access the index in the 2D array? Okay, so it's a basic mathematics. If we have like this matrix, if we want to call the 10, okay, the second row and the second column, the element this number have the element of 2 and 2. Okay, 2 and 2. Okay, so if we want to access the element of a matrix, you can use this. Okay, so it means that in this this is the first row and the first column. Remember that Python starts from 0, so any index starts from 0. If we want to access 1, we'll pass 0. Okay, if you want to access 5th index, you have to type 4. Okay, so this is the first row and first column, first row and this and sorry, this is the first row. Okay, the first row and the second column. Sorry, the third column. Okay, the first row and the third column. Okay, and if you are going to print all of the rows, all of the elements in the second row, you can use this directly. Okay, and the column. So to summarize that, if you are building a 2D array, in this inside this bracket, there are 2 numbers. Okay, the first number corresponds to the row, and the second number corresponds to the column. Okay, so if we want to access all of the elements in the second column, you can use this semicolon. Okay, semicolon means that it's all the elements in the 2D array or in the matrix, and this is the second column. Okay, I think that's understandable. So after this, we're gonna detect about like a non-numerical elements in our array. Okay, so actually we can create this array consists of nan or non-numerical values. Okay, So this script detects if there is any non-numerical values in our array. Okay. So if there's any, it will return true. Okay. True, because there are non-numerical values in our arrays. Okay. And the following script, you can delete or the non-numerical values from the arrays. So if you print this script, you will see the numerical values only in the array. Okay. So what's the meaning of this? This is not okay. Okay, so let me clear about this. You see that this is none is to explain that there is a non-numerical values in this array, because we want our result to extinguish all the non-values. We use this. Okay, so it's understandable. Not none, not numerical values. It will print the numerical values. Okay, and then if we want to imputing, so imputation is the important application in any engineering applications. We often have lots of unstructured data right there. If you are working in the industry or in IT industry, you will have non-ideal data. You have unstructured data. You have lots of blank columns and blank rows with non-numerical values, and you have to impute that non-numerical values with a certain number. So it's called an imputation, and this is important because we don't want to lose our data. Some people right there likes to delete this non-numerical values. So if we are having like thousands of data with 500 of non-numerical values, people often delete this non-numerical values, so we only have 500 data. It's not preferable because we delete the data and we lose the information from that data. So if we the another alternative to do so is that we can impute those non-numerical values with a certain number. There are lots of imputation methods. You can impute the non-numerical with the average of the data. So here, I want to impute all the none or the non-numerical values with 0. Okay, so if we run this code, okay, so actually this is only the same like what we had before. Okay, and then we just type equals 0. It will replace all the non-numerical values with zeros. Okay, and if we want to replace this non-numerical values with average of the data, okay, so we can calculate the mean or the average of the data easily first. Okay, so for example, we have already the array. Okay, these are our arrays, and if we want to compute the average of this data, okay, we use this. Okay, so the average is 16.7. Okay, and if we want to impute, originally we have this, okay, my array. Okay, this is our original data, and we want to impute my array, the none values, with the average numbers. So we have already gotten this number. We just type this one. Okay, 16.7. Okay, so it will replace all the non-numerical values with the average of the data. Okay, or you want to type your own numbers like 100. Okay, it will replace the non-numerical values with 100. Okay, And the another important thing is that sometimes you want to search a number, whether a number exists in your array. For example, we have this array, okay? We want to search what index is the number 80 in our array, okay? So we can pass this in this script, any, okay? Any means that this code will search over this array. Is there any numbers of 70? Okay, if we want to search for 90, okay, it's resulting true because there is 90 in our array. If we type like 1, it will return false because there is no 1 in our array. Okay, so how to know our index in this, the index of, for example, 100. Okay, 100 is from this. Okay, we can use this method np where. Where is my 70 in my array? Okay, so you can pass this code to access the number of the index. So we know that 70 is our 6th index of this array. Okay, that's pretty simple. And if you want to type to search the index of all numbers below 70, okay, you can pass this. Okay, this is the conditional operation. Okay, if we run this, it will print all of the index. Okay, and replace all values that are less than with a certain values. Okay, okay. So if we want to, okay, so if we want to replace, okay, we have this array. Okay, we want to replace all of the numbers below 70 with 100. Okay, it will appear as 100, 100, 100, 100. Okay, 70, 80, 90, it's the original. So we can use this code to replace all of the numbers below 70 with 10. Okay, so you can produce your new array with all of these numbers below 70 as 10. Okay, okay, so it's you already understand how to create an array. So the next thing is that you can read a data from any source of data. For example, here you have a text file. Okay, so how to read a text file? You can first you need to specify the path of your file. Okay, so on the first in the first time I discussed about GitHub. Okay, and all of the data for our training is stored in our GitHub. So the way we see lots of the data in our training today, we go to the left, to the right, to the left pane. Okay, so and then you search for the data, and the data that we are going to use for the reading text file is this syncosttext.txt. And you need to specify the path first by clicking copy and then paste the link. Okay, it will read the path. Okay, and then you load directly the text file using np.load, and it will print all of the data from your text file. Okay, and if you are going to know the dimension of your data, you can pass .shape. Okay, what does it mean? Okay, so we have 1,000 rows with 3 columns. Okay, in the before I explain how to read this conventions, Python conventions. It's same like you read a 2D matrix in mathematics, or in matrices, mathematics, or in calculus, it's similar. So this one corresponds to the rows, and this one is the columns. Okay. So you guess this is the 2D array. Okay, the matrix. Okay, so we already know how to operate with NumPy. The next thing is that we want to plot all of this data. The library to plot the data is called Matplotlib. Okay, so the data that we are going to plot is that you are already you have already have the data. You have already called the data. You have already read the data. We just access this data. Okay. So actually, this data is just like is just a sine and cosine function of a certain number. So x is the first column of the data, and then the sine of x is the second column, and the cosine of x is the third column. So we call each of these arrays, okay, by using this. We just run this, and after reading all of these variables, we can just plot all of these variables using plt.plot. Okay, but you guess that this plot is not beautiful because we don't have any title, we don't have any labels, X labels. Oh, by the way, if you want to, we can switch the appearance of Google Colab by clicking this settings, and then you just select light, so you will see the light color. Okay, so it will brighter right now. So you don't find the title, and then you don't find the legend. Okay, so what we are going to do next is we want to add the title of the plot. Okay, by using this. Okay, so we have already plotted each of this data. First, we want to specify the size of our figure as 10 and 5. Okay, 10 is the length and 5 is the width of the figure. Okay, and then you this is how to give a title of the plot, and then you want to add the labels. And this one you want to restrict because in the first plot you haven't restricted the x-axis from 0 to 350. Okay, so you can limit your x-axis with this, and then you want to label each of this curve. We are using this label equals the name of this curve, and then another label for another curve, and then we don't forget to run this PLT legend. If you didn't previously you didn't run this PLT legend, it won't show this label. Okay, if we run this, you will see a more beautiful plot. Okay, all right, we can also resize this title by using size of the title 20 and size of the label its axis as 15. Okay, we can do whatever with Matplotlib. You can modify this plot. It's really advisable to beautify your plot. It means a lot when you are presenting to another people, or you are referring this plot to our coworkers or our friends. They will be interested if our plot is more colorful and it has lots of details in it. Okay, it's the importance of visualization. We visualize the data, and we ensure the people to understand what we are visualizing. So that's the importance of visualization. Okay. And next, we want to make a subplot. Okay. You already know what is subplot. Actually, from if you are using MATLAB, subplot is that you want to make a plots, make sets of plots, 3 plots. You make multiple plots. You're gonna use this plt.subplot. Okay. So first of all, I want to make a data that consists for trigonometric functions with different formulas right here. You just click run. Okay. And then we will plot off all of the results, okay, using subplot. And what I want to do next, I want to plot all of this trigonometric function into 2 times 2 subplot. It means that it has 2 rows and 2 columns. Okay, so each of this function, we specify the location of the plots. Okay, so what does this mean? It means that we want to place the first function. Okay. Okay. So in these numbers, it says that we will have 2 times 2 plot. So it has the 2 rows and 2 columns. Okay, because it will record the location in order. So it will start from 1, 2, 3. So if I run this code, we will have this plot. Okay. So the first trigonometric function is placed in the first sequence. Okay. First sequence, and then the second trigonometric function as the second, third, and fourth. Okay. So so sometimes you want to plot more than 4 plots. Okay, so we just modify this. If we want to, for example, you want to make a subplot with, actually we only have 4 functions here. So if we want to, for example, like we want to make a subplot that consists of 3 columns, sorry, 3 columns and only 2 rows. Okay, you will pass this how many rows? 2, and how many columns? 3. Okay, because there are 6 plots, you will place all of these locations in order. Okay, so the first plot will be 1, and then 2, 3, until 6. Okay, so I think it's understandable, and it already have the title in each plots and the labels in each axis. Okay. Okay, so actually we are done with the Matplotlib. It's really easy to start. The most important thing is that we have to communicate from our visualization to another people as clear as possible. Okay, so if you are seeing this visualization, I believe that you are much more interested to see this plot rather than this one. Okay, I believe so. And the next thing, we will be introduced to Pandas. Okay, okay. So first thing first, Pandas is a library to handle, like an Excel, we handle with spreadsheet. Okay, but in Pandas, the terminology is different. It's called the data frame, and Pandas handling with the data frame, like we handle spreadsheets in Excel. Okay, and the data that we want to use right now, I just list down all of these companies. Okay, I just make this data. The data will consist of the name of the company, the country, the origin country of these companies, and the date when all of these companies were built. Okay, so first of all, because we already know about how to make an array with NumPy, it's really easy for you guys right now to make an array. First of all, we have to make an array. Okay, the name of the company. Okay, if we run this, we already have 3 arrays. Okay, it's always started by arrays. Whatever we are creating a data frame, you have to start with an array. That's the most important thing. Okay, if you understand what is an array, you understand what's a data frame. Okay, and then if you want to display your data into a data frame, like, you pass this script. Okay, it's different on how we print all of these arrays using the NumPy. Okay, like previously we print the company. Okay, so it's not a data frame and it's not too nice to look at. It's nicer to look at into this kind of data. So data frame is a foundation of data science and machine learning. Okay, and in this data frame, we already had a company, country, and date founded. And we're gonna add some columns in our data frame. But first, we want to print all of the data in the company column. We pass this company df. Df is data frame. So this one, okay, this is the data frame. And each time you want to operate or you want to use this data frame, you just pass, first of all, this data frame. And then if you want to access the first column, the company column, you use this. Company. Okay. Or date founded. Okay. Another method to, if supposing we don't know the name of the column, okay, if we don't know the name of the column, for example, we don't know that the first column is named company, the second country. We use this method. We always have to remember these things. Okay, I have explained many times about how to define an array. So, for example, if we have like 8, 2, it means that this one is the row. Okay, this is the most important thing in all script. Okay, the 8th row and then the second column. Okay, so if we want to apply this method into a data frame, we can pass this. We want to access all of the elements, all of the data in a country. The country is located in the second column, and all means the semicolon. Okay, semicolon, comma, 1, because the second column. Okay, sorry. The iloc. So the iloc means that we will access all of this information in the second columns. Okay, so this one, okay, it means that we're gonna access this the second row in our data frame. We use this, and it will print the Equinor company. and the country and the date founded. And if we want to convert back our data frame into an array, we use this dot values. Okay, but we just want to print all of the elements in the company column, not the other column. So we just pass this this syntax with the values. Okay, it will print this one. Okay. Supposing we want to have we want to add another column, like for example here you want to add a column that consists of the number of employees in each companies. Actually, this data I got from Wikipedia, and I consult with some of my friends how many employees they estimate, and then this is the best number that I come up with. So supposing if you want to complain these numbers, I think this is the best number that I have right now. Okay, so this I just create a new array, and then we want to add an array by using this syntax. Okay, and it will add another data frame. And the another thing is that using data frame we can compute the summary statistics. For example, the average and the standard deviation. Use is described. Okay, and then also it is really important before we are handling with time time arrays, or with the time data that is like it has time. We have to convert the time into a datetime format. It's a format from data frame. If we don't convert this data, this time into a datetime format, we cannot access it later. Okay, so this is important because in the third session we will talk about how to visualize our production data. So this one is really important. If we have like the production data from certain date to another date, well, some companies or some institutions, they have different format. Like date format there is really diverse. So the datetime format, it standardizes all of these formats that is made by the operators or made by the petroleum engineers behind the data into a datetime format so that we can visualize it in Python. Okay, so the way we convert our datetime format and how we know that it hasn't been standardized. Well, if we run this code, you will see here it's called an object. If you find this object, okay, it means that this date hasn't been recognized with the data frame. Okay, so if you, for example, you want to, sorry, it's a kind of like I'm using annotate, but I haven't cleared yet. Clear all drawings. Okay, so okay, it's pretty complicated to use the annotate in this feature. Okay, so if we already know that this is not the datetime format. The datetime format must be datetime. If we use date type, it has to be datetime. So if we want to convert this format into a datetime format, we pass this format. Okay, it will recognize the way we specify our datetime. Actually, this is not a numerical, but it's a string. We have to convert this into a numerical values. Okay, and using this format, you just run this. It already convert the datetime. So previously we have this format, right? And then after converting into our datem format, it changes into this. And if we pass, if the company, okay, the data frame company, it's already in this format. First, we have object, and right now we have datem format, okay? So I think it's all about how to operate with a data frame right now. Actually, you can follow all of these steps. It's actually the same how you access the elements in the information in the data. It's the same as you are accessing the elements in the 2D NumPy array. Only the difference is this iloc method, okay? And then how we slice a data frame. Actually, this is quite tricky to slice a data frame, because right now we combine all of these methods, and it seems to be confusing for you guys. It's okay, because it's the first time. Maybe it's the first time for you to use these conventions. I also experienced lots of difficulties at the first time I learned Python because all of these conventions. But if you start learning about these things slowly, you will understand what is the meaning of each of these code that I explain right now. So if you are going to slice a data frame, you can use this code. It tells you that this one, okay, the first is the row, okay. I have already explained it many times. This is the row, number of rows, and this one is the number of columns, okay. It means that we want to print all of the elements in the data frame. So we pass this semicolon, and then we only want to slice the first to the third column of the data frame. So we use 0 to 2. It will access all of the data in this range, okay? And then if we want to slice the data into its rows, like only this row, you can use this. Actually, it's logical. They are nothing for you to memorize all of these things. It's pretty logical. It's kind of like, it sounds similar to how you handle with NumPy. Okay, how you handle with NumPy is really similar on how you handle with data frame. The method is just similar, like a similar convention. You only just have to practice all of these things many times. Okay. Okay, so this is the fun part. Anyway, we have spent lots of times about, right now we have spent about okay, more than 1 hour. It should be like in the second session right now, but it's I think it's okay to go follow this in about 5 minutes, and we are going to analyze the registrant data. So I just got this data from the committee, from Boyke and Michelle. I asked them for the registrant data in the CSV format, and in my leisure time, I was quite interested to see the participants. So I want to end this first session with the analysis of the registrant data. So I have already stored the registrant data for training, okay, in our repository, okay. So first thing first, we need to specify our path. It's easy. We just copy path, copy and paste into this, and we just run this once. After being loaded, we open the data using Pandas, okay. And this one is the registrant data. As we see here, we have 3 columns with non-numerical values. It is not supposed to be here, so we need to delete these columns, okay. And the another thing is that instead of looking all the data, you can just see the first 10 columns using head, okay? Or you want to see the last 10 data, you use tail, and you will see this non-numerical rows. So what we are going to do now is that we want to clean this data from these non-numerical values. That's the objective of this analysis. First of all, when you are analyzing a certain data, you have to look at the data, and then you have to check whether there are some non-numerical values in the data. Okay, and then you clean the data. So you already know that the pure data is started from the first column to the third column. Okay, so we just because in previously we already discussed how to slice a data frame. Right now we want to apply this method to slice this data frame and delete these rows. Okay, so using this slicing method, okay, you already have the clean data. Okay, but the thing is that you still have the non-numerical rows in the data frame. So you will delete this three last rows. Okay, so we delete it. Okay, so it's already finished. We already have the clean data. Okay, and then I want to search how many registrants in this course. Okay, so we use this count. We will count the names. Okay, there are 449, around 450 registrants right now. Although I'm sure that how many participants right now? I think it's already growing right now. Okay, so and the next thing is that I want to visualize the distributions of the major of each registrant. Some of you guys, mostly of you guys, are from petroleum engineering and geophysics and geology, but some of you are from astronomy. So I want to visualize the distributions of the majors into a pie diagram. Okay, so bear with me because it's interesting. So first things first, we just we print all of the majors. Okay, some of this data is in Indonesian language, some of this is in English language. So we have to use a certain technique to extract all of these majors. So we use this. Okay, so drop now means that because we want to visualize a pie diagram, and we don't want the non-numerical values in our data, you just run the drop now. Okay, and it will all delete all of the non-values. Okay, and then we'll start counting the majors, and then some of the data is Indonesian language. So petroleum major, I have already counted the petroleum major. Some of you guys from abroad universities, and some of you guys from Indonesian universities. So I just combined all of this data into one number. Okay, this one is for petroleum engineering major, and this one is for the geophysics major. After we run all of this, okay, we sum all of these numbers. We already have how many majors in it. We just click, for example, how many majors from marine major, marine engineering, there are some, 1 participants from marine engineering, or from chemical major, there are 7 participants from chemical engineering major. So after this, we want to distribute these numbers using the pie diagram. I've prepared these codes to create the pie diagram. So this is the final result of this distribution. We can see clearly that from this result, around 65% of the registrants and the participants are from petroleum engineering, and the second rank is from geophysics, because me, myself, I was studying geophysics when I was in my bachelor degree. So it must be like the second largest distribution is from geophysics, okay? And then geology, and then mechanical engineering, electrical, chemical. There are lots of majors coming in this session, okay? So I think this is the end of session 1. I hope that all of you guys understand what NumPy is, what Pandas and Matplotlibs, and how to apply all of these things. Later, after this, in session 2, we will apply these methods to a real data set, to an exploration data set. So I think I have to take over my mic to Boyke and Michelle. We will have a 10-minute or 15 minutes break to all of you to understand all of these things. I know, because it's quite stuffed in just 1.5 hours. I'm sorry if this explanation seems confusing, but I believe that if you practice this all of the times, you will understand all of these things. Okay. So for Michelle or Boyke, you can take over my mic, and we can answer some questions from the chat. I just see lots of questions powering my chat. Okay.
Okay, Mr. Yohanes, thank you so much.
That was very interesting, right, guys?
Okay.
Now, for those who have any questions regarding to the discussion, you can push the raise hand button in the participants tab, and you'll be unmuted. Please state your name and where you are from. If you're a student, state your
Boyke,
university. Yeah.
Boyke, we have some questions in the chat feature. I think some is interesting. I think first we will answer these questions first, and then we'll allow some participants to open their mic to greet all of others if they want. And okay, so I can see your questions in the chat features. I really appreciate it, guys. It's a good questions.
Okay.
It's going to be discussions. Okay. So from okay. Okay, so for the issue, like from FICAS, the answer for highest to lowest is wrong, I guess. I've already cleared that. Okay, so it's if we sort the NumPy using the method that we used previously, it will sort the element from the last to the first, not the highest number to the lowest number. Okay. Okay, so from Iramar, I know you talk at the beginning, but so some of the participants want to know how to clone, repeat what we need to clone at the beginning and how to do it. Okay, so I will briefly go over it first. Okay, so is my screen visible to you right now? Or I need to share my screen again?
Yes, you can share your screen, Mr. Yohanes.
Okay.
Right now, it's not showing.
Okay.
Okay. It's
So
showing now.
here, okay. So here, first of all, we type this script, okay? Git clone, and this is the path, okay? So this is the GitHub repository. And in this GitHub repository, you have the link here. You just copy this link and then just paste in this space, and you will clone. Actually, the reason why I'm using cloning right now, because some people are prefer to store all of their data in GitHub. Okay, so if we can stream all of this data, if we can clone the whole repository. If we clone the repository, we will get all of the files, all of the programs, all of the data into our Google Colab. Actually, if it is not advisable to, it is not recommended to like clone. It's optional for you guys. If you have GitHub, you can clone your own GitHub into your Google Colab, so that you can use your codes directly in the Google Colab. Or if you just look around some GitHub repositories out there from experts, they share lots of codes, they share lots of programs. You can just access all of their repositories using this cloning method. Okay, so I think I will also like, okay, so another question.
Okay, once again, for those of any questions regarding to the discussion, you can push the raise hand button in the participants tab and you'll be unmuted. Please state your name and where you are from. If you are a student, state your university and major. You may now ask your questions.
Can we color area between two curves? Yes, you can. Okay. In this session, because it's really brief, I don't put the codes on how to put the color between the curve, but there is a certain method to do so. And then how can we set the grid size of X and Y axis? You can do that. Okay. But the question is how. So in Matplotlib, you have the method is called plt.grid. In those plt.grid, you can specify the grid size in the Matplotlib. Okay, so you can have the grid size control in your plots. And can we apply this code to Python? Of course, because you can access this code in any IDs that you use right now. You are using Anaconda. You can download this notebook, and then you can start all over in your Anaconda. Okay, Iramar, you're welcome. And my question is, after downloading the codes from GitHub, how should one approach to practice coding? That's a really interesting question. Thanks, Narendra. How should one approach to practice coding? Okay, if you clone a repository, actually I have some suggestions for you all to start. There are lots of good GitHub repositories to learn Python. For example, like I follow Professor Michael Pierce. If you have already heard about him, he's really good at geostatistics. Okay, so I like to follow all of his courses about geostatistics. He's really wonderful, and he's also have a repository in GitHub. I think the name is Geostats Guy, and then I will share the link after this. Okay, so in this repository, you can find all of some introductory courses, and if you clone this repository, you can start learning these codes into practice. Okay, for example, here I want to share my screen again right now because it's really interesting to see his repository. It's really good for you to know about that. It's really advisable. So here For example, this is one of his course. Okay, just go to the lectures, and you okay. So this one is not the PDF. Okay, so this is the notebooks. You can open these notebooks, okay, directly in your Google Colab. Okay, so if we just see this inside, you will see the notebook. Okay. Okay, so this one is his notebook when he's explaining about geostatistics right here. Actually, I also have some GitHub repositories to start learning Python for reservoir engineering problems. We can solve reservoir engineering problems using Python. You can just directly access these notebooks into your Google Colab. So for example, you want to search my notebook. I just recently made a reservoir engineering repository where all people can learn how to solve reservoir engineering problems using Python. Okay, so actually you can go through this file, open notebook, and you type the name of the repository owner. Okay, so for example, this is my repository, and then I search for my repository here, reservoir engineering. Where is it? Reservoir engineering. Okay, reservoir engineering. Oh, there you go. Okay, so there are some notebooks that I created. Okay, for example, we want to open some of these notebooks, like Unit 1 or Unit 2 review of rock and fluid properties. You can just click this link, and you will be directed into the notebook. And you can start practicing your codes directly in that notebook. Okay, so actually Google Colab is really fun for learning. Okay, you can modify the codes, you can practice the codes directly without having to download all the data into your PCs. I know that exploration and production data is really big in size. So without having to download all the data, you can just access it into the Google Colab. So for example, here you can run these codes. Yeah, I think it's really simple to do all of this.
Okay, I'm sorry, Mr. Yohanes, but I think the Q&A session is enough for now. Is it possible if we continue to the second session, because yeah, the time is still running?
Okay.
Okay then.
I'm
So
sorry, you guys, if I'm taking lots of things in just 1.5 hours. Actually, it's supposed to be like in separate sessions, but I hope that you all guys can understand what I'm talking right now. Okay, so if some of your questions are not answered, you can directly type your questions in a Telegram link, and I hope I can answer some of your questions right there after the session. Okay, so so I'll directly go to the second session. I guess it's already over.
yes, okay. So that marks the end of the first Q&A session. Now we are going to move on to our second session, which is a view on exploration data streaming and basic petrophysics using Python. So Mr. Yohanes, you may now continue to the second session.
Okay, guys. We have already understand how to operate with NumPy and Pandas and Matplotlib. Okay, so the most important thing is this session. We are going to continue our journey in the second session. Let me start sharing my screen right now. So we back to our first notebook. Okay, I hope that you are following me right now. So this is the first notebook that I showed to you previously, and in this notebook you can click directly for the second link. Okay, the second session. Okay, so yeah. we have already downloaded this this GitHub notebook. Okay, I think that it's like, okay, so it's already streamed right now. Okay. Right now we are talking about how to apply Python for exploration. In petroleum, there are two domains, exploration and production. Exploration, this I want to explain all of you guys that there is not from petroleum engineering. So I hope you understand the tone of my explanation. So I'm gonna explain what is exploration, what is production in brief, okay? Exploration is the domain when we explore some fields, okay? Some geophysicists and geologists, they are collecting lots of data from the field. For example, like geological data, we have well log data and then seismic data. This stage of exploring all of this exploration data, yeah, it's called the exploration stage. And the production means that after the field is producing hydrocarbon that we want, we already have the data. For example, the production data, the production data, rate, pressure in the wellbore. It's called the production domain. So after the field is producing some hydrocarbons, it's called the production stage. So first of all, we want to apply this Python to exploration. Okay. So first thing first, we just connect to the notebook. Okay. And as usual, we import all of these libraries because we already know how to import that. Run anyway. And then after importing these libraries, you can directly go to the data. Okay. So let me first explain what the data for our training right now. We are using a well log data from a real data set. It's from the Dutch F3 dataset from the Netherlands. Okay, this dataset has certain seismic data and well logs. There are 4 wells that are documented in those dataset. And right now we are going to access these 4 well logs. Okay, for these well logs for visualization. Okay, so I have already stored the data into our repository. You can see here. Okay, so so actually right now we don't have to clone this repository because we can just directly copy and paste the location of this data. Okay, because sorry. Okay, so let me go back to my repository, the Python, the Git, the bootcamp for geoengineers. We have the data right here. This is the data that we want to stream directly into our Google Colab. Okay, so we just copy this this URL and paste it in our script here. Okay, so if we click run, it will download the zip file into our Google Colab. So it's important here because we stream the data directly into our Google Colab without downloading the data into our PC. So it won't consume your PC space for downloading the data. You can stream directly into your PC without consuming your space in your laptop. Okay, so that's the fun part of using Google Colab. And then after this, you already had the data into your Google Colab. Okay, and then the next thing is that we want to unzip this file because this file is in zip format. We have to unzip. Only in this Google Colab right now, what we are doing is quite similar in how we do in our PC. We use RAR or zip software to unzip, but right now we code certain codes to unzip this this file. Okay. Actually, it's not too difficult to code to unzip this file. It's only this short lines. But here, as you see, when after you download all the data, you have like the name of this is not set enough. It should be .zip. Okay, so you can rename the file so that your script will read that this is the zip file. If you are, for example, you are, okay, so actually this is a zip file, but because this name is not zip.zip, this script won't recognize, okay? So if we run this code, we want to unzip it, there is no way to download because our name is wrong. It should be .zip only, okay? So we just delete all this text, okay? And then if we run this code, it will unzip successfully our data. Okay, so it's important to take note in this stage because some data is not ideal. The format is not ideal. Sometimes you have to modify the format. It's called the data analysis. You have to do pre-processing first before you analyze the data. Okay, and then here you already have the well-logs here. Okay, it is stored under this directory. So some of you guys, if you don't understand what well-logs, actually well-logs I made to go to my presentation right now. We are going to analyze some strata of the rocks from this data. So basically, well-log tells if you are going like 2 kilometers down below the surface, you will see rocks. But can you dig that deep? Of course not. You just measure the properties of the rock using well-log techniques. There are lots of properties because we are handling with physics. Okay, physics is the most fundamental part of all applications in engineering. We measure the physical properties of the rock, and you will come up into these different properties. Here is the gamma ray. Don't worry if you haven't learned about this. It's the data that we obtain from the rocks. Okay, so this one is a gamma ray, density, porosity, Poisson's ratio. Okay, that's really a trendy name from French name, Poisson's, and then the VP or the P velocity. We have all of this data, and we want to interpret what's the rock beneath my feet. For example, I'm standing here on top of a shale rock. Okay, so I can analyze this well-log data, okay, into this crossplot, and with this crossplot technique, we can distinguish each rock by using these properties. So right now we are analyzing the rocks using well-log. Okay, so we are back to our discussions, the Google Colab discussion. Okay, so this we used. Okay, so let me start right now. We already has this one, the dot last. This is the well-log. Okay, the well-log data. So we first specify the path as we originally do many times. First, in the first session, we specify the path by using copy paste. So this is a similar thing. Okay. So I just designed the first course for you because in the second and third session, all of these methods that we have already discussed will be repeated again to apply these methods to your needs. Okay, so it's really important to understand the first session. After you are following this session, it is advised to you to repeat the first session before you apply to your needs. Okay, so the next stage is that we install. This is Lasio. Lasio is a library. It's relevant to NumPy. It's relevant to Pandas. Only Lasio is a library to to process well-log data. So it's a special library. In Python, there are lots of developers developing their own programs, their own libraries, like Keras TensorFlow is for machine learning, neural network, and also geoscientists out there, like me myself. I'm studying right now in petroleum engineering and reservoir engineering. Of course, I'm developing some of the libraries that that you can use for your needs. They compile all of these libraries so that we can use it. Okay, and Lasio is one of the libraries that we can use for the well-log interpretation. For seismic, we can use that is called SecYO. It's from the Equinor. Okay, so there are lots of libraries right there. So here we will use Lasio. So first thing first, you'll need to install Lasio. Okay, so we can use this pip install. I think it's for you if you are already familiar with the Python scripting in the command prompt. You're already familiar with this thing. Pip install Lasio is what you want to install the libraries. Okay. So in this Google Colab, you can also use these things relevant to your use in your command prompt. And then you can import the Lasio directly. Okay. So I forgot to install this library first. You just need to wait for certain minutes to finish the installing, and then we use the Lasio import Lasio. Like we use import numpy, we always start with import libraries. Okay, so so someone is chatting right now. Someone is having problem. Let me see the chat feature, if I can see that actually, because okay, so we'll answer your problem after we finish some of the topics that I want to discuss. Okay, so this one is that first you can read the well-log using lasio.read. Okay, so that's surprising because before I just find the error message, but right now it's okay. So this is a blessing, actually. Okay, so we have already read the data, and then we always want to look at what is inside our well-log data, whether it contains density, porosity, or sonic velocity, or gamma ray. We can inspect all of these properties in our data by using this .keys. You can see all of the properties in our data. Okay, this might seem confusing to you when if you don't learn about these things, but I hope that it's understandable to all of you guys. You just open all of these properties by using keys method. Okay, so here I have rho B is the density, and the depth time, gamma ray, acoustic impedance, AI relative acoustic impedance, and the effective porosity. Here I just view one of the well-log. If I want to search, for example, like the third log, okay, so I can see that in this second data I also have this properties. Okay, actually it's not a complete well-log data. In exploration, we also have like gamma ray that's right there. Resistivity is important for us to distribute the fluid saturation inside our rocks, because resistivity is not here, so we can. I think it's okay. We will cover the petrophysical analysis without calculating the fluid saturations at the end of the session. We will only calculate the porosity using density and the porosity and lithology. Okay, so after this, we are interested to know what units are we using in our data. So we use dot curves to inspect the units that we are using in our data set. Okay, so in density we have kilogram. Okay, so this is the standard unit, and dt. Okay, this one, okay, is a microsecond per m. We need to convert that because some people prefer some units. There are lots of units out there. Field unit, in pressure we measure psi, but in imperial or in in metric we use Pascal or even bar, or in in depth or in dimension we use feet for the field unit, but in metric unit we have meter. So later we can convert all of this data into our own units that we want. Okay, but first of all, it's important for you to identify what units are we using right now in our data, so we can imagine how to convert this data later. For example, I want to convert this unit into gram per cc. Okay, so it's really simple to identify these units. And the next part is that we want to visualize this Vellog curve. Okay, this is the most important stage in visualization of Vellog data. This is the first important thing before you analyze or before you conduct petrophysical analysis, whatever it is. You have to look at the Vellog data first carefully. So here we want to visualize our Vellog curve, okay, using Matplotlib. Okay, remember that Matplotlib is a library for plotting. Okay, but here we also have the data in a data frame format. Okay, you remember Pandas. Pandas is a library for data frame. Data frame is another format other than NumPy array, and this Vellog data is stored in a data frame format. So the way we call the Vellog data is similar to the way we call the data frame. Okay, so if we want to call the density of the density column, we use this. This is our data frame name. Okay, actually, if we want to view the data frame, I guess, okay, so it's I cannot see the data frame right now, but this one is the data frame. If we call this with each of the column name, you will see all of the data. Okay, for example, we run these codes. Okay, it should be understandable for you all. Okay, if I want to print this the row B or the density, okay, you will have this data. Okay, and next we want to visualize it, because I already prepared the script for you. It's already simple. You already know how to make a subplot. We already discussed that previously. We already know how to beautify our plots, okay, using all of the attributes, and some participants are recommending to use to fill the plot with a certain colors, or to add a grid to the plot. It's a really interesting suggestions that, thank you, and I will try that later, and I will add this feature later, and that's a very good idea. And right now I'm going to visualize this Vellog data with the methods that we have already learned before. Okay, so basically it's quite the same. We specify the size of the figure, and then we give the title, and then each of this I have 4 subplots, and each of the subplot I want to plot the density, sonic velocity, the gamma ray, okay, and the impedance. Okay, just use this script, and then we can limit our axis and title. And then if we run this codes, okay, Okay, so that's the well-log visualization right there. Okay, so you have different colors. Colors are really important for visualization. It tells a lot about the data. Okay, so instead of having a monotonic colors like uh, only black, it's advisable to visualize the data into colors. Me myself personally, if I look at the data, I really like colors. So it's kind of like I can get a new insight from that. Okay, so yeah, I like colorful visualizations. And here we already have a visualizations that's really colorful. We have already had the title, and then this one is the depth. Okay, don't forget one thing. In well-log visualization, we display the depth into a reverse order. Okay, so from the top with the the ground datum, we use 0. Okay, and then up to the 2 kilometer down into the earth. Okay, so we have to carefully specify this axis. If we don't specify this, the limit of our y-axis, starting from the maximum of our depth and the minimum of our depth. For example, if we we ignore this, okay? If we ignore this thing and we run this code, then you see, you will get your y-axis not into a correct order of visualization. That's really important to consider when you are visualizing well logs. You have in Python, okay, specifically in Python, you have to specify your limit. So what does it mean? It tells you that from this this plot, you want, this is the minimum value and this is the maximum value, but you want to visualize it in the reverse order. So it will start from the maximum value, the 100 meter, to 0. Okay, so you can specify this maximum value to minimum value, not the reverse order. Okay, so if we go back to our plots, okay, and we run this, we already had the correct order. Okay, and this one, don't forget to place all of the descriptions in the plots, because it means a lot for other people to see your well log. Okay, so I think it's not too important to explain all of these well logs, because I believe that some of you guys are studying petrophysics in your university, or some of you guys already working as a petrophysicist or as a geologist. You already know how to read the well log data. So I think I will skip these explanations on how to read the well log data, because it's a Python course. Okay, to the next step. Okay, so I just want to help you visualizing the well log data in Python using various methods. Okay, so another visualization that we usually made is the cross plot technique. Okay. So we're gonna go directly to the basic petrophysical analysis. Basic petrophysical analysis. Okay, the basics of petrophysical analysis. First, you can visualize the data, the distributions of your properties using crossplot. I don't know why some plots are really magic for me personally. I use crossplot many times to characterize a reservoir from the distributions between the density or the sonic velocity, and I personally recommend of you using the crossplots when you are analyzing. Of course, for university students, you have to start from the crossplot. Of course, you have to start from reading these well logs to get the insights. Of course. But you can modify your data into a crossplot. You just plot, it's really simple. You just plot the y-axis and the x-axis. It's really simple. Okay, so from the data we have already had the gamma ray properties and the density. Okay, so imagine that in the first we don't have this with this plot, and we use scatter method to cross plot these properties. For example, we want to cross plot between the density and the gamma ray of the rocks of the well rock. We just run this, and we see the distributions of our properties. Okay, so if we want to distribute all other properties like what we all have here, okay, dt and AI, okay, I think that's a high correlation with those properties like def time and the AI. Okay, so this is the cross plot of our properties. Okay, so you can modify what properties that you want to show in your cross plots, and don't forget. Okay, one thing, don't forget to place a title, because it really means a lot when people read your visualization. Okay, the gamma ray and the Roby. So let me add the title, for example, cross plot between def time versus acoustic impedance. Okay, dt, we have the units of microsecond, and the AI. Okay, AI is the multiplication of density and sonic velocity. So it will have the version of kilogram times meter per second. Okay, it depends on the units that the well-log data has. Okay, so it's already complete right now. Okay, and it has also the color bar. And in this crossplot, we can see the distributions of our properties in the shallower depth and the deeper depth. This one corresponds to the, it corresponds to the deeper depth, okay? Concentrates in this zone, and the shallower depth concentrates in this zone. For petrophysicists, this visualization is really important. They can distinguish different properties of the rock by seeing this crossplot. Okay, so after this, actually, I want to explain a bit basics about how we can extract all of these informations using crossplot techniques. So I think it's already finished with the crossplot. So we go directly to how to convert. This is important because in petrophysical analysis for geophysics, they prefer to have the sonic velocity rather than depth time. So we need to convert the data into another unit. Okay. So first of all, you see that the depth time has the unit of microsecond per meter. In sonic velocity, you want meter per second. So you can directly convert the data, the depth time data, into the sonic velocity. So using this formula, okay, I think it's really familiar for you guys. So we convert the data, the depth time to VP, okay, and then I want to visualize the original log, the depth time log, and the VP log, okay. So we just run this, and we just see the converted log at the right plot, okay. And then what we obtain from this visualization? Well, we see that our data ranges from 1.5 kilometer per second to 3 kilometer per second. Okay, that's the range of our rock velocity. Okay, so after we convert it into VP or P velocity, we can also produce the shale volume from gamma ray. V shale tells you how much clay or shale volume in your rock. So for example, you have a rock, a sandstone sample, and you have like a little amount of shale in it, you can count the shale volume of the rock, okay? And the well log has the gamma ray properties that we can compute the shale volume in our rock. Why shale is important? Shale is important because we have to know what pay area that we will produce from our field, okay? So the less shale we have in our rock, so actually it's assuming that our rock is an unconventional reservoir, sorry, conventional reservoir is not unconventional reservoir where we talk about the shale gas or shale oil. In conventional reservoir, the less shale we have in our sandstone rock, the better the rock is for our reservoir. And the higher amount of shale, it will be good as the cap rock, okay? If you already know the petroleum system, you know what the cap rock is, you know what the reservoir is. It controls all of these things. You know that these properties using the well log, okay? So actually, it's a really introductory topics that you have to understand in your university. You have to understand all of these concepts in the back of your mind before you are looking into your data, so that you can have the essence after you are converting the data into your desired results. You know what the result is for your purpose, okay? So right now we use the fish shale, we use the gamma ray to produce the shale volume. So this one is the formula. You might be really familiar on how to compute the gamma ray. And this one is, okay. So actually this is a bit complicated for you, but I want to just go over this. Okay, so first of all, in our data, we have some non-numerical values. If we take the minimum values and the maximum values of our gamma ray data, because the gamma ray data has a non-numerical values, it will return also as non-numerical values. We cannot see the minimum and the maximum values of the gamma ray because it contains a non-numerical values. So the thing is that we're gonna do right now is we want to impute this NAND data using the average of the gamma ray data, okay? So I already make a function. So actually I forgot to tell you guys, this is the way I make the function in Python. So for example, you have an array, for example, like a equals np.array 1, 2, 3, 4, 5, and then you want to make a function to add each of these elements with the certain numbers. Actually, it's really simple, like add elements. This is the name of the functions, and then it returns an input. And then you just type the function like sum np sum, okay? Because I want to compute all of this, to compute the sum of this array. So place a, and it will return sum, okay? If we run this, we already run the function. We just call the function. Sorry, it's not add elements, but sum elements. Like sum elements a, and it will return you the sum of its elements. Okay, so that's the way you define a function in Python. Okay, so the same here, I already made a function for replacing the non-values in the gamma ray, because we have the non-numerical values in our gamma ray. I want to impute these non-values with a certain average value of the gamma ray. So first in this function, I remove all of the non-numerical values from the gamma ray. So the input here is log. The log can be any, for example, gamma ray dt or sonic velocity. So it will replace all of the non values in the log using this, and then I will compute the mean or the average value of the array. And then we have already talked it before, actually. It's just to replace a certain non-numerical values with the average of it. So we pass this, the log equals mean, and we return the new or the modified log. If we pass this function into our log, okay, so we just run this, it will print us all the log with the all numerical values already replaced by the average values. Okay, so this will be like this. It doesn't have any numerical values right now. Okay, so because we already impute these non-numerical values or the incomplete arrays, we can specify the minimum values and the maximum values of our gamma ray, and we just directly compute the official calculation, and we can visualize our shell volume. Okay, and then this is the first petrophysical analysis. We already has the shell volume, and the next thing is we want to compute the density porosity from the density data. Okay, because in the density data, I suppose I don't find any numerical values in the density data, so we don't use this function anymore. Okay, and we just directly derive all of this derive this formula, and if we run this, it will calculate the density porosity. Okay, be careful that density porosity is not the effective porosity, because the effective porosity we got from the combination of the density porosity dphi and the neutron porosity or the nphi. Because we don't have neutron logs in our data, so we cannot compute the effective porosity. So yeah, so I just calculate the density porosity only, because there are no neutron logs in the Dutch F3 velox. I hope that I can search for it somewhere. Yeah, and then so let's display our porosity log. It's the same method actually. Okay. Okay, so actually that's a basic conversion of our velox data into our desired properties. Okay, we have already computed the shale volume and the porosity, the density porosity. Okay, and if you carefully look into this, if you are a petrophysicist or if you are loving petrophysics, you will disagree with me. Why? Because in any porosity, you won't have a value of porosity larger than 45%. Okay, so this one we we have to cap this one. Okay, but because we just stated, we just assume our values of it. Okay, so it will return you an incorrect result. Okay. Okay, so the last part of our second session right now, we're gonna cross plot all the plots, all the logs. Okay, we have the subplots. Okay, right here. I just close this, and then using the same method, you want to place the rho b, the density, and then the VP. VP is already converted from our def time log. Okay, and then rho b versus shale volume we have already computed before. VP versus density porosity, and this versus this one, and the VP versus Shale volume. If we run this, we will come up into a cross plot of different properties. Okay. In the meantime, it's not too important to discuss what does this cross plot mean. It's important for you to understand how to make a subplot and then how to compute a certain properties from the data frame or from the VLOC. Okay. So actually, there are other libraries like Seaborn. Seaborn is used often to make such this crossplot. Okay, but sometimes I feel that Seaborn doesn't have any kinds of these details of colors. Actually, we can modify more codes to fit with this purpose, but I feel that using pure Matplotlib, it feels a lot for me to modify all the codes. Okay, so actually this is all that in the second session. Okay, so actually that's the end of our second session. We already spent about 1 hour. I think it's a good. I think yeah. So we'd better to have a break right now. I just want to answer some of the questions in the question and answer. So yeah, okay. So Boyke and Michelle, you can take over my mic again, and we'll discuss the questions.
Okay,
One thing, yeah,
yes.
I think you can because there are lots of discussions. You can help me reading all of those comments, so I can also read all of some questions and I can answer in this break time.
Yes, of course.
Yeah.
Yeah. Okay. Now we are going to begin our second Q&A session. Okay, I'm gonna read what's in the chat box. So
Okay.
we have an. Okay. Yeah.
Yeah. Okay. Go on. Okay.
Okay. There is a question from, is this Miss Vikas? Wait a minute. Oh no, I'm sorry. Before her, there was Mr. Raihan Izzat from University of Indonesia. He asked, can Matplotlib support FEA models? For example, when we're making a geomechanical model of an open hole,
Okay.
maybe.
Okay,
Yeah.
that's a good question. Thank you. So FEA, I suppose that's a finite element analysis. Okay. For FEA, I suggest not Matplotlib because Matplotlib is the basic plotting library for actually it's for common purposes. But FEA or geomechanical modeling or any simulation, you can use what is called as PyVista library. PyVista is really cool to visualize some objects in a mesh, like you know about Delaunay or Voronoi mesh. In PyVista, I hope that those meshes can be visualized, because in Matplotlib so far I haven't found any FEA application in Matplotlib. Okay, I hope that answers your question. But that's a good question. Actually, I also know some people that's really good at FEA. Some of my friends are from mechanical engineering. They use PyVista and they use kinds of like, for example, Gmesh. Gmesh is software to make a mesh generated object, and then you can visualize with a Matplotlib. Okay, so I think is there any question? I think there are lots of questions in here.
Okay, I see another question from Yustian Eki. He asked, which method is preferable to fill the, how do I say this, NaN or none values in the log? In the course material, you mentioned the use of average value. What are the pros and cons?
Okay, Mr. Yustian, thank you for your good question. I appreciate your your participation in this course. I really appreciate it. So first of all, if we are using the replace none with the average values, actually there are lots of methods to replace the none values with any numbers. We already discussed about imputation. Imputation is a broad terminology for this application. And the applications of machine learning and neural network, they help people to impute the data. And of course, the method that I use to use the average value, it's not the most accurate, or I think it's not advised for an expert in data scientists or experts in petrophysics to use this method, because it's only the basic method that we can impute the non-values. We can also impute the non-values using any machine learning methods. But the important thing that I want to show all of you right now is that the importance of imputing non-values with any numbers, because we often delete this data which have a certain non-numerical values, and we already have a little portion of the data. Okay, we don't have much. We don't have lots of information from the data because we have kept some portion of the data. It is better to replace this non-value with a certain algorithm, whatever it is, KNN or like SVM or regression. You can use all the methods that you want, but I think that average value is a really method to impute the data in our log.
Okay. I think we have time for one more question. I see from Stefano. He asked, may I know what is the advantages of using Python in terms of visualization? Because I believe we can make cross plots in Excel as well.
Okay, so can you repeat the question? Sorry, from Stefano.
Yes, he said, may I know what is the advantages using Python in terms of visualization? Because he said that cross plots can be implemented in Excel as well.
Okay, so that's an interesting remark. The one that you cannot do with Excel, maybe I can be wrong, is that you cannot produce. Let me share my screen again. Okay, so okay, let me share my screen. Okay, so in Excel, I believe you cannot have this continuous colors. Okay, so in Python, you can modify. Actually, this is not the standard. This is not the only one color in Python or Matplotlib. You can specify other colors, for example, rainbow or seismic or red, blue, white, and it tells you lots of insights from the data. But the most important thing is that in Python, you can visualize this continuous. What I say, this is continuous color bar. Okay, if we cross plot this data in Excel, I believe, or maybe I can be wrong, there is no way to visualize these colors, although it can, but it cannot be continuous. Okay, and of course, we want to work efficiently with all the cross plots in Excel. I hope that we cannot make this sets of plots like this, the subplots. And in programming language, not Python, but any programming language, the essentials of visualizing your data is that you can customize by yourselves and you can get lots of features rather than using spreadsheet. Although spreadsheet can be easy at certain times when you don't have to code, and I use Excel before I know Python, and for me personally at the time, I'm really confident that I can do all of things with Excel, but after I know Python, I think that Excel has some limitations. Of course, we can do lots of things with Excel, but in Python, we can customize lots of plots with our own interests. I hope that that answered your question. Okay, maybe I want to answer some quick questions. Someone is asking about, can you repeat once again the name of the library for seismic? Yes, it's called the SecYO. I will type after this. And then how to look or get only a particular section of well log, like from depth 200 and 600. Okay, Vikas, you can limit the YLIM. Okay, so I think I want to look the other questions, so I can cover all the questions after I share the screen. Could you please show the last file actually looks like? Actually, you can download the last files, and then you can show in your laptop, because in Lasio there's no way to show the whole the whole last file, only the portion of it. And then how to look at, okay, the target area, okay. That's really good comments. Thank you guys. You are very active right now. I really appreciate. I'm really appreciative. Okay, so how can change scale values after plotting? Change scale after plotting? Yes, we can. We can use the X scale method. Actually, I don't code in the current session, but I think it's a good idea also to add that feature. But we can. And then how can we change the scale in logarithmic? That's a really good question. Okay, so in Matplotlib there are lots of kinds of what we call it, the scale, and we can modify the logarithmic scale. Okay, actually in production data, for example, in well test analysis, when we analyze like wellbore storage period or the infinite acting time for the wellbore to reach the boundary, we use the Horner time. And some plots really need like an in logarithmic plot. But and here in Matplotlib we can use this scale, and later I will show to you after I share my screen. Okay, so could you tell us about pairplot, how to visualize and interpret it? If we have more time after this session, I will show it because it's really brief and it's really easy. And then, okay, I think that's long comments right here. Okay.
But sorry,
yeah.
Mr. Yohanes.
Okay, I think
this the remark of the end of second Q&A session.
Mm-hmm.
Maybe now let us move to the third analysis about well test and decline graph analysis.
Okay, guys. Okay, so let me share my screen and we'll discuss briefly. Okay, so let me share my screen right now. Can I share my screen? Okay, I will share my screen right now. Okay, so let me briefly introduce you. So in here you can use the logarithmic plot here by using this PLT, but the scale is logarithmic. Okay, and then you can. Okay, so I think that's all the questions. We'll go over your questions after all the sessions are finished. Okay, so and we are talking right now about production data. In production data, okay, just go back to our notebooks, and then we just search for the third session. Okay. Okay. Actually, if you have any questions, I just see lots of questions of you are. I'm really glad to see all of your questions and comments. And if you want to arrange a certain offline meeting after this session, I will be really glad to answer all of you, or I just upload my answer in YouTube so that you can get all of the answer at once. Okay. So right now we are continuing to our third session with production data. Okay, this is the most interesting thing I believe for petroleum engineers, because you petroleum engineers must be waiting this for a long time. We just spent sometimes with the introduction, but right now we are going to apply Python to the real data set. Okay, so as usual, we just connect this Google Colab, but I want right now to change my screen to dark so it looks more comfortable. Okay, so okay, run anyway. And then we clone the repository because the data is in the repository. Okay, so one person is asking about reservoir engineering. Yes, I created the repository, and I use only just basic libraries like NumPy, Matplotlib, and Pandas to solve most reservoir engineering problems. And I have to say that all problems can be solved using those three libraries. So I have talked to you before. If you master all of these libraries, you can solve any problem that you want. Okay. And for this production data, actually, we are going to talk about the specific application in reservoir engineering. Some of you guys have been familiar with the decline curve analysis. Decline curve analysis. Let me share my presentation again. Decline curve analysis is a way to forecast our production data. Okay, I just wait for it for the okay. In session 3, we will discuss about decline curve analysis with Python. So, for example, you have a production rate data, okay, and from the production rate data, it tells you lots of information from it, okay. You can forecast the production data in the coming 5 years using decline curve analysis. There are lots of methods that we know in reservoir engineering to extrapolate our production rate data in the coming 5 years, for example, the reservoir simulation. But decline curve analysis is the simplest technique, but it's really robust to to forecast this data in the coming 5 years. It's really simple. Okay, why it's really simple? Okay, the most basic part of decline curve analysis is that we have the production data, production rate data, okay, and we use certain function, for example, the hyperbolic function, okay. The hyperbolic function was introduced by Arps in 1945. He proposed decline curve analysis to forecast the data, and we feed our data with a function, okay, and then we extrapolate the function so that we know, not we know exactly, but we can estimate how much production rate and of course the cumulative production, okay, how much barrels that I can have in the next 5 years, how much cubic feet of gas I'm gonna have in the 5 years, okay. So it's really, I think it's really important to know all of those informations for investments or for other things that when we're gonna develop our field, we have to know the time span of our field, and we have to forecast this through the production data. So let me go back to our notebook. Okay, so in this tutorial, we have a production data that consists of 2 data. The first data is the borehole flowing pressure, okay, and the second data is the production data. So in this directory, you can see the data here, the production rate data, okay, and the BHP data. It's the borehole flowing pressure, okay, and then you just load the data, okay. You just load the data using Pandas because we are handling again the data frame for our data, okay. And then it's already displayed here with the first 10 rows of the data, and we can see lots of non-numerical values of the data. And then when we look at this column, okay, if we print this column, okay, you already know how to take a certain data from certain columns. You just pass this, okay. You just see again, it is an object, not a datetime. So we have to convert this this data into a datetime format. Okay, the way we did this is we convert the datetime into the datetime format in Pandas data frame, and then we use like this format, and then the PHP data, and then we just look the data after conversion. I think actually it still looks the same, but if we pass this data once again, it already corrected to datetime. If you don't convert this datetime later, you won't plot this plots, okay, in a correct format. It will print as a string that is not desirable for us. Okay, so we have to always convert this data frame, the string into the datetime, so that the Python can read it. Okay, and then we also have another data. Sorry, this is still the same data, and we want to visualize it. So, okay, so this is our data. Okay, so as you can see here, there are 3 wells with a flowing pressure that is recorded in bar, not in PSI, and later we can convert. Okay, so you have already know how to operate the NumPy, to how to multiply an array. So that will be really simple. But in this training, we'll only use one of the wells, which is the well F. Okay. Actually, through the end of this session, this data is meant to be a certain application for the well test analysis or the production test analysis. But because of time limitation, I only leave this data. Later, if I have another session with you all, we will explore this data and we will apply some well test analysis from this data. Okay, but for this session, we will discuss only the decline curve analysis. And the decline curve analysis, we won't use this data. We just want to use the production data. So this is the whole flowing pressure, and if we just want to plot all of the wells, we just delete this, okay, this wells, and then you can visualize it. Okay, so that's only the one well. Okay, and then we also load another data, the production rate data. This is our main data for our decline curve analysis. So you can directly load the data. And as you can see here, again, you see that the datetime format, okay, it's not the Pandas datetime. It's still the date format that is specified by the makers of this data, of course. So we have to again convert this into the datetime format. So it's really simple. Actually, we have to pay attention more on how to convert this, because, like, for example, we have lots of formats like the days coming first, like today is 13th of September 2020. Some might write down as this, or some, sorry, okay, and some like this. There are various ways to write down the data. Okay, so if we have to handle this different format, you have to standardize this first. So that's the importance of converting the string into the datetime. So after conversion the date time, okay, we can display the production data of all the wells. And this one is the display, okay. And for this training, we only use the well F. Okay, so this is the visualization of the production rate data. Okay, and the next one is if we want to zoom in certain the year, for example, from year 2002 to 2018, we can zoom it. Okay, so because previously there is a question on how to restrict my data from depth to depth, this one I will show you how to limit this access to your interest. Okay, so the only thing is that you only pass this script. It defines the start date and the end date. Okay, if we run this code, okay, it will limit only the x limit of the of the plot, okay, of the production plot and the well flowing plot, okay. And then why I'm zooming in this region? As you guess, this is a really nice build up, okay. In well test analysis or production test analysis, it's really interesting to look at this kind of build up or drawdown. This one is the drawdown because the pressure is going down, okay, as the fluid is coming in our well bore. And this one, if we shut in the well, meaning that there is no flow in our well, or we're gonna inject fluid in subsurface, we will have a pressure increase in the well bore. From this information in well test analysis, we can compute the permeability, the skin factor of well bore. There are lots of results that we can get from well test analysis. So the reason why I'm interested in zone because I can analyze this this data. But for this training, we will only discuss the decline curve analysis. So I'm interested to visualize. Sorry, I want to show you the complete production data. So I want to extrapolate the production data from this curve. Why? Because it is the last stage of this field. Okay, as the production production rate depletes, we can forecast how much time we still have for our production. Okay, so it's really important to forecast from this data. So that's why I use this this range. Okay. Okay, so you can play. Actually, you can play with the dates. If you want to you want to visualize from this date to another date, for example, like from to 1999 and 5 December. Okay, and you'll get your interest. Okay, and you can see here. Okay, so this one is the build up that I showed to you earlier. Okay, so that's a really good data that we can do certain production test analysis if we have time for that. I'm sure. Okay, so and then so this one is the production data, and the next part we will do the decline curve analysis. But right now, you see that our production data, we have lots of outliers right here. Okay, there are lots of outliers that actually we have to not to impute, but to remove these outliers. We have lots of methodologies to remove these outliers. For example, we can use the rolling average. Let me write it for you, like certain methods for outliers that you can try at home. First is the rolling average, and using machine learning. Okay, using machine learning, for example, you can use like tree-based models, or so actually from the rolling average you can compute the standard deviation of the data, and then you can, from the standard deviation, you will control that all of these outliers that is outside our standard deviation to be removed. Okay, so that's the basic explanation of rolling average. And of course, machine learning helps you a lot in removing these outliers to detect the anomalies in our data. But for now, we will skip that, okay? So we assume that our data is smooth. We assume that our data is a smooth data, okay? So without removing outliers, we just run this cell, and we will, here, I define the variables, okay? The variables are the time and the Q. So the basic knowledge or the basic practice of decline curve analysis is that we have this y-axis as the Q, okay, as the small q because it's rate, and the x-axis is the time. Okay, so I specify this T and Q. Okay, and this you have the data. Okay, and you will fit this. Okay, so after you run this this cell, you already specify all the variables, and then this one is tricky because in decline curve analysis, you often fit the data with the time data, and the time data must be ordered in a numerical ways, for example, from zero, day 1, day 2, day 3, day 4. So let me clear about this. Here we saw the time axis is still in date, okay? And in decline curve analysis, if we want to fit our data, we have to change this x-axis into days. So 0, 1, 2, 3, up to, for example, 300 days. Okay. So the way I'm doing here, so you don't have to be worried how I write this code. You can practice it after that. And actually, this one is the list. Comprehension. Earlier, I haven't explained what is list comprehension. List comprehension is the way we can accelerate our so let me put into a simple explanation. If we have an array from 1 to 10, we want to compute the difference between the next element to the first element. We often use for loop, but using the list comprehension, only this one line you can compute the difference without for loop. So the meaning of this line is that we have the dates, okay, and we want to compute how many days are between two dates. So I use this to compute the difference between the dates, and then because the result of this is in a list, we can convert this into a NumPy array, okay, and then so here, okay, so I think it's better to explain one by one, okay. So we already had the time delta. It's stated as how many days between certain date, okay? But we want this result only contains this numbers, not the whole information, okay? So if we run the following code, and then we run the code, it will change all of these informations, okay, into the numerical values. Okay, if we run this, okay, the result will be only the numbers. Okay, so after this, we cumulative, we summing over these differences to make a cumulative dates. Okay, it should be really, it should be understandable for you, because I think we have to pre-process our data carefully before we are doing certain analysis using Python. So if we compute with this line, and then we have a result, this is the cumulative dates, okay? It should be understandable. And because we still have an object here, it tells you that this is not a numerical or float. You should be careful on this. So you should convert these strings into float, okay? And one thing, you have to add certainly 0 to the first, okay? And then the float, just run this. Okay, because I have to run from this cell, and then, okay. So if we run the T, it will print not the object but the float. So you have to be careful on this, okay? So after you have all the data for the time axis, now we are going to plot the production data, okay? So this is the production data. We already have the time axis as days. As before, we still have the date time format, okay? And then now we have the days format. So we are ready to fit this data. And the next thing is that we will fit this data with the hyperbolic function, okay? And in this application, we will use SciPy, okay? SciPy, SciPy.curveWidth, okay? And using the curveWidth method, you can fit this data, but you have to be careful because the SciPy fit curveWidth method, you need to normalize your data. What is a normalization means? It normalizes your data from 0 to 1, okay? So if we normalize this data, okay, we normalize first each of the time and the rate. We now have a result like this, okay, from 0 to 1. Okay, this is important before you do certain nonlinear regression for your applications. And if you compare with the T before normalization, yeah, you guess you have this days, but already normalized into this result. Okay, so and then we define our hyperbolic function. It should be familiar for you all from petroleum engineering backgrounds. This is the hyperbolic function. This is from the ARPS function. And next, we use the curveFit method to fit the regression. Okay, so I think I should explain this more because okay, so after I have made this function, we import first the libraries, okay? And then after importing libraries, we use this function to call the function, hyperbolic function, and then we input our inputs after normalization. And as you guess, as you fit the data
with a hyperbolic function, there are three parameters. The first is the initial production rate, okay? The second is the initial decline rate, and the third is the most important value, which is the decline exponent, okay? So in this result, I have, this is the initial production rate, initial decline rate, and this one is the decline exponent. So if we stack these values into our first function, this exponent 1 over b is this 0.5, the decline exponent, okay? And because we have already normalized our data, we have to re-normalize. We have to get back the NumPy array from normalization into the denormalized data. So we can use this formula, okay? We can use this formula. I think it's understandable because let me share the derivations of it. I think it's really important for you to understand this. You have, okay, so you have okay, so this one is the function, the original function, and then you already normalize this data, the Q normalize equals Q divided by the maximum values of Q, okay? And then the T, okay, T normalize is T over the maximum value of T, okay? And then if we are going to denormalize these values, so this one becomes Q over maximum of Q, and this becomes T over maximum of T, okay? It will move here. So the final output, okay? The final output will be this equation, okay? This the maximum of Q move here, and then this is the normalized, the denormalized T. So we multiply our initial production rate from the result with the maximum value of the rate, and we have to divide the TI, or the initial decline rate, with the time, the maximum time. And if we run this result, we have the correct result, okay? This one is the initial production rate, okay? And the decline rate and the decline coefficient. And of course, we are interested to forecast our data in the coming 5 years, okay? So we are going to extrapolate this data using the fitted function. So first, you specify the time for your forecast, and then you pass these parameters, because you already have the parameters in your data. You can forecast this this data, and then finally we can plot our forecast. Okay, beautiful. So here we already have the curve extrapolated to certain days. Okay, so with this decline curve analysis, you can forecast how many production rate that you expect when it's coming to 5 years. Or you may limit your EUR, or economic limit, for your production. You can set here, so it will tell you how much time we will have to reach this EUR. So in the development phase, you can manage the pressure and manage the production rate, or even we can implement EOR to span the lifespan of our life. And decline curve analysis is the basic application of reservoir engineering practices. Actually, we have lots of applications in Python for reservoir engineering, in Python for petroleum engineering. For example, recently I just wrote some articles in the LinkedIn in the meantime, I want to share a series of applications of Python, Python tutorial for solving some problems in reservoir engineering. For example, I already wrote an article about aquifer influx with Python, how we compute the production data to get the how much water influx coming into our reservoir. Also, I have wrote an article about the volumetrics. If some participants here are already trying out the codes in my tutorial, and in the upcoming articles, I will share some more applications of it. For example, the gas material balance, the oil material balance, lots of applications, the IPR. We can solve all of these problems with Python. And I could say that Python is it's really powerful to do lots of sophisticated applications. Okay, so I think this is the end of this third session. We already discussed how to handle the production data. We have already discussed to visualize this data. And if you are following my post in LinkedIn, you will learn more how to implement Python with lots of applications in reservoir engineering. So I recommend you to learn all of these things in your own pace. Don't stop learning Python, because when you stop learning Python, that I experienced sometime when I first learned Python from a course, and then I stopped for a month, and then after I continued a while, I just forgot how to state a numpy array. So it's really important to continuously learning the codes that I show to you in today's tutorials. So I hope if you have any questions for this session in session 3, or of course, actually we have a free time right now. If we want to cover some questions from the first session to the second session, third session, we can cover it all right now. So I think I'll take over my mic to Oike and Michelle again.
Yes, okay,
And help
thank
me
you.
with the questions.
Yes, thank you, Mr. Yohanes. So in the chat box, I'm seeing so many amazing people that are commenting and asking. They're very interactive, I think. Yeah. There's actually
Yeah,
like a combination of questions I see from, there's a question from Mr. Muhammad Idris. But I think his question is also the same as Mr. Marco. They're asking what are the advantages of differences. I mean, what are the advantages or differences using Python with real data? Because we know the well-developed softwares are the best tools for simulation or analysis. As Mr. Muhammad said, like Eclipse and Petrel, Sapphire, and so on.
Yeah, of course, that's a really interesting remark. We have lots of softwares right there, but the question is that, do you understand exactly the workflow behind the software? Or you just like use the software and you just get the results, but you never learn how to make your own workflow with a programming language. The essence of learning programming language is not how to achieve the result, but how you learn the algorithm. And of course, what is the advantage of not just Python, but all programming language is really advantageous for all people, is that we can automate this process in certain softwares, like when we handle, for example, 1,000 of well-logged data, we just input one by one, okay? But in Python, we can create our own algorithm to automate this process so that we don't have to input all of this with this log data. For example, in North Sea, there are lots of data, there are lots of wells there, and you certainly don't want to input all of those logs in the software, and it spends lots of times for inputting that. Meanwhile, it is really good for you to practice your patience on inputting the values. But in Python, you can create a simple program that can automate this inputting so that it can spend only 3 or 4 minutes to input rather than spending some 10 minutes and 15 minutes to input all of those things. And then about other softwares like for simulations, we have lots of simulation softwares like TNAV or Eclipse. They are really good softwares, and the importance of programming language is that we can migrate. If you know the term about data migration, we can migrate different format from Eclipse, for example, to TNAV, and certain softwares has their own certain format. So we can make a script to change this format into another format. So I think that the knowledge of programming language is becoming a really important for you all to start looking at this importance, I think. So I think, I hope that answers your question, but that's really a good remark.
Okay, thank
Yeah.
you, Mr. Yohanes. We're going to move on to the next question. I'm seeing from Mr. Yustian Eki. He's asking, based on your experience, what is the best algorithm to extrapolate this production rate? Also, what kind of best method to do the model evaluation?
Actually, because this course is open for you all with any backgrounds and introductory. Most of you guys are from introductory level. I think the most appropriate answer to this question is that any algorithms that we make is the best. Okay, so there is no best algorithm that can automate this process. Okay, there are lots of algorithms proposed by any people, but if we can design our own algorithms, we can learn from the website on how to automate. Of course, we don't have to use machine learning anytime, because some of you guys are really interested in machine learning, but the question is, do you understand exactly what programming is and what algorithm is? So it's more important to make an algorithm and you understand the algorithm, and then you understand how to use the algorithm to meet your specific needs. For machine learning, there are lots of models, SVM, KNN, like for automation, we use like in Python, we have list comprehension. That's the basic strength of Python to automate this process to certain kinds of big data. For example, the production rate. We can automate this process if we are using the correct algorithm and we are designing the best. We are designing a good algorithm to do that all the times. Yeah, and I see that there are other questions here. It's becoming lots of comments, like I just skipped when I was talking, lots of codes. So I think it's okay. So I will go another question. Okay, okay. I'll go with a technical question. So some of you guys who are still confused with some codes that I have already coded, so we can go first for that question. Okay, so can a line be drawn within the plots to separate the flow units? Can a line be drawn within the plots to separate the flow units? A line be drawn, as I'm not sure if my interpretation to your question is right or wrong, but maybe can a line be drawn? I think yes, of course, and I think we can modify the distance between two subplots or more subplots, so we can see clearly the values in it. Okay. So another question, like okay. Okay, some good questions here. Okay, so from Marco, I think. What are the advantages? Okay, so I've been answered that. Is there any of you guys still have technical like confused with certain codes? You can certainly put your questions in the chat feature, because if you are confused with certain codes, we can go back for a while and then we can continue with some non-technical questions. Is there any of you guys who are still confused with this?
I think there's a question from Rishab Kumar. He asked, in Python, can the algorithms relays the workflow of the Petrol software?
Relays from the Petro software?
Yes, he is asking to Mr. Rishab. Maybe if you want to ask more, can you open your mic?
Okay, so I encourage you all to
Yes.
you can open your mic as well.
Yes,
Okay. It's a free time right now.
to all of the participants who wants to ask Mr. Yohanes directly, you can unmute yourself, or you can raise hand first so we can unmute you and you may ask your questions.
Thank you, Iramar Veskus. Okay. Okay, yeah.
Hello.
I can hear you. Yep.
Oh, can I speak?
Yes, we can hear you.
Yep.
Yeah, I was asking, like in the Petrol software, we do a similar type of simulation. What you have shown in the current Python language. Okay, so whatever do we do, like analysis, time structure analysis, time thickness analysis, the same thing can it be done in Python?
Okay, I think you are asking about black oil table, right? The black oil table in Petrol.
What? Can you repeat?
The black oil table in Petrol.
Yeah.
Maybe whether or not we can like relate some workflows in Petrol with Python. I hope that's your question, right?
Yes.
Okay. So thanks for the question, Risaf. That's a really good question. I really appreciate it. This is really interesting how we can relate some workflows in Python with some softwares. In recent times, I see lots of like plugins right there, Python plugins for softwares like Eclipse. They have certain plugins, Python plugins, to convert certain file format from Python to from data frame to Petrel, and then it will convert into an Eclipse file. Yeah, it's possible, and we can also make our own program to relate our data that is coming from our Python to the Petrel. For example, like a black oil table, we can relate the codes to the Petrel and the Eclipse. And then there is one library that I know it's really good to read an Eclipse file in Python. It's called the libcl. It's from Equinor. So libcl is a library to open an Eclipse file in Python, and then we can modify this, modify the files, and then we can go back to Eclipse whatever you want. So I think there are lots of plugins right there to relate these codes to any software that you use right now, CNF or any softwares, and it's really important to use that in any of your works and any of your studies right now. Yeah.
Okay. Thank you so much.
Yes. Okay. My pleasure.
Excuse me. Yeah. Can I speak?
Yes, because
yes, sir.
hello.
Yeah. Hi, Yohanes. This is Vikas from University of Portsmouth. I have a question regarding the decline curve analysis. Sorry. Hello. Sorry. I have a question regarding the decline curve analysis. we sometimes have very low values in the middle, due to low production or shut-ins. How do we avoid such low production values in kind of when we try to use the Python coding or use the hyperbolic equations and stuff? Thank you.
Okay, thank you, Vikas. Yeah, that's a good question. May I share my screen right now? Because actually your question is in my is in our data right now. So I will share the notebook once again. So actually, I think this is your question. If we have clear for drawing, we have this type of data. This is the Q and this is the rate. It will sometimes start from the low points, okay, and then it will go up and then it will falls down into the hyperbolic. And it's really simple to delete these values. You just slice this data, okay, from certain times, and you will see that your data have already fit to the highest to the lowest. So we can delete this by using slicing methods.
Okay.
So for example, you have like a data right here. We can slice the data, and then you can easily delete all the unwanted portions of the data. And your question becomes really important because I already discussed previously, we have lots of outliers here. So it's not always on the start of the data, but it's found all over the data. So it's really important to have some kinds of outlier detection to remove this. So I think if I got another time, I will show how to delete these outliers. So we will have a pretty clean data.
Yeah, because I believe that gives a issue with the estimated ultimate recovery in the end. Because if you have to,
sure, yeah.
All right.
I agree with you. Yeah.
All right. Thank you so much.
Yeah. Yeah. Thank you, Vikas, for your good question. Because actually, if we have like unclean data, we have to clean this first, and then we will have a pretty accurate parameters for our decline curve analysis. So it's important of looking into our data first before we are going to do another steps after that. Okay. So is there any question of you guys?
I believe if there are no more questions, we are at the end of our session for today. Maybe if you guys want to ask a little bit further or want to ask more, you can ask by inside our Telegram group or WhatsApp group, or maybe you can connect with Mr. Yohanes by LinkedIn, as he has mentioned before. Yes. So
okay, thank you guys for your participations. I just see lots of you are joining in this course, and then it's humbly really surprising for me to see lots of these participants. But I want to say thank you for you all. You have joined this session, and thank you as well for your good comments and your good questions. If I may greet all of you guys here, but because this limited by space, I just want to share with you all from my knowledge in skills in Python, and I hope that you can also apply this Python for your studies. If you are studying, it's really important to know about programming language. It's becoming a trend right now. Not because of data science or machine learning trend, but because programming has been really important for you to start improving your skills, your analytical skills. And I'm really thankful for committee of SP Trisakti for holding this session. It's really great session for me, and I hope to see lots of you guys in another opportunities. And if you have any questions, or you want to greet me, or you want to have a chat with me, or you want to greet with each other, I recommend you not to leave the group, because because we designed the group for interactions, or if you want to explore lots of more codes, you can ask there directly, and then we can discuss that directly in the group. So I hope that you guys will be successful in your studies, and I hope that you enjoy the course.
Okay, then thank you so much, Mr. Yohanes. So we have that marks the end of our third Q&A session and also marks the end of today's course. Alas, we have arrived at the end of PETROWEEK course 2020. We've learned a lot from the Honorable Mr. Yohanes Nuwara about Python programming language. And for those who have asked about the video, yes, this video will be recorded and it will be uploaded to the SP Trisakti SG Student SC YouTube channel. So don't worry, guys. And we will also provide the link to your email as soon as possible. And there will also be a form at the end of this session. So please don't leave right now, because we will send it very soon.
Yeah, thank you guys. I'm still in Telegram, so if you want to poke me directly, I'm in Telegram, so you can contact me directly. Or
yes.
maybe better if you have LinkedIn, because sometimes I'm a bit active in LinkedIn than in any social media. So maybe you can greet me there in LinkedIn if you have my LinkedIn. Or you can contact me in Telegram. That's okay. And I hope you guys enjoy this course and don't stop to learn. Okay. And that's all from me. I hope you enjoy your day.
Yes, now we are at the end of our session. Now, before we end our session for today, we are going to have another photo session. So please, to all of the participants, to open your camera and open your mic so we can see again your beautiful and handsome faces once more. You may open your camera. We'll see you guys right now. Okay, are you ready, guys?
Yeah.
In the count of 3, you guys say PETROWEEK, okay?
Okay.
1, 2, 3.
PETROWEEK.
Okay, we're going to do it once more on a count of 3. 1, 2, 3. PETROWEEK. Thank you so much, guys.
Thank you, Mr. Yohanes.
Okay. Next, we are going to move on to our memento session. Yes, to Mr. Yohanes Nuwara, we would like to give our biggest gratitude for being the honorable speaker for today's course, PETROWEEK course 2020. We would like to give our biggest gratitude, and this e-certificate will be given to you and sent to you by email. And also, we would like to thank our sponsors for today, to ExxonMobil Chipo Limited as our gold sponsor,
Telkomsel as our gold sponsor,
Medco Energy as our silver sponsor,
Premier Oil as our silver sponsor,
PGN Saka as our silver sponsor. Wow, guys, what a day, right? Or should I say a grand week? Today's event will also mark the end of PETROWEEK 2020, jam-packed with loads of grand and competitive events throughout the week that will be sure to boost your quarantine up. From day one, a grand seminar was held with the theme Applying Digitalization to Maximize the Potential of the Oil and Gas Industry, which discussed more about the new era of technology for the oil and gas industry. And for 4 days, 4 different competitions have been held, which is paper competition, mud innovation competition, case study competition, and smart competition.
Splendid. And don't forget about today too. Thank you to all of you guys who have participated in today's course. To Mr. Yohanes, we also like to thank you for the time and knowledge you have provided for us today. In the end of this session, there will be a questionnaire. To all of participants, please fill in the form as the attendance for today.
On that note, a few words before we part ways for today. Education is a passport to the future, for tomorrow belongs to those who prepare it for today. You are never too late to learn something new, nor to dream a new dream.
Okay, guys, remember, don't forget to wash your hands, use face masks, and bring hand sanitizer.
Stay at home and stay safe and healthy. My name is Michelle Keja, and together with my partner,
I'm Boy Kadeo, signing off.
see you guys on our next events. Bye, guys.